Good morning, class.
Good morning,
Good
teacher.
morning, madam.
Good morning. Okay, we
Good
need to
morning.
start. Yeah, good morning, everybody. Okay, I'm going to start the lesson today with what you have done last week in the Google form, if you still remember. Okay, I'll let you see the Google form first. Just now I checked already.
Good morning.
Good morning. There are still 19 of you who haven't handed in this yet. It's regarding the lowest common multiple. Hope you still remember. So you can see the name of those 19 of you if you are present now today. Okay, I think Ahmad Dawisi is the same person again. Dalisha, Dayang Masha, Dayang Norgis, Gabriela, Iskandar Zulkarnain, Madiha, Magdalene, Muhammad Haris, Muhammad Habib, and Muhammad Hekal, Naifah, Nur Atika, Nur Azalia, Nur Shazira, Nur Aina, Sharifa, Shakira, and Yusuf Zamir. Okay, I'm sure some of you are present today, so make sure you, after this lesson, go back, do it, replace it, and hand in to me. Okay, so I'm going to discuss the answer right now. So for those of you who haven't handed in, make sure you get full marks in that case. Okay, so before I start with the lesson today, I'm going to enter the new chapter today. So before I start with it, I'm going to go through what you have done last week regarding the LCM. Okay, so for the first question, they ask you to choose the correct answer for all of this. First question, determine whether each of the following numbers is a common multiple of the list of numbers in the bracket. So if you want to find out whether it is a common multiple, for example, is 72 a common multiple of 9 and 12? So you have to use any method up to you. You can use the listing, the multiples method, repeated division, or the prime factorization. So I'm going to use the one that is easier, which is the repeated division method. Okay, so you just write down 9, 12, and then divide by the prime number until you cannot divide anymore. So over here, the number that can be divided, that can be used is 3. 3 times 3, 9. 3 times 4, 12. Divide again, 3, 3, 1, 3. This remain the same because we cannot divide. And then we are going to divide it using 2. 2 times 2, 4. Divide again, so 2 times 1, 2. Therefore, the LCM is equal to 3 times 3 times 2 times 2. Okay, so it is going to be 3 times 3, 9. 9 times 2, 18. 18 times 2 is, 339. 9 to 18. 18 times 2 is 36. I think I made some mistake over here. Is it 9? 9, 9, 12. Check again. 3, 3, 9, 3, 4, 12. 3, 1, 3. 2, 2, 4. 7. Oh, yes, it is. Okay, so the first lowest common multiple is 36, but then they ask you to determine whether it is a common multiple only. So common multiple, when you multiply 36 by 2, you get 72. When you multiply 36 by 3, so you get 108. So all of these are common multiple. Therefore, 72 is a common multiple for 9 and 12. Okay, so that is how you search for the rest also. The rest that is correct are this. Okay, you are going to use, up to you. You can use the repeated division method like this. Find out the lowest common multiple. After that, you multiply 2, 3, 4, 5 to get the number in front. If you can get the number in front, means that they are the common multiple of the number in the brackets. Okay, so I continue with the second question now. Okay, second question is this. 360 and 600 are the third and fourth common multiple for the following. So which one is the answer? The answer is already given, so I'll just let you see how to solve the question. 360 is the third. So I write down the third is 360. The fifth, meaning that we have 4, we have fifth. So the fifth number is 600. 300. So we are going to search for the second number and also the first number. If 360 is the third, so you can see 360 divided by 3 is 120. Therefore, the first one is 120. So followed by the second is 240. So we are going to check this one from, I check it directly with the answer given, 3, 5, 8. So you are going to find the lowest common multiple of 3, 5, and 8. 3 times 1, 3. So this one cannot divide anymore. And then we are going to use 5. So this is 5, 1, 5. And then 8, we are going to use 2. So 2, 4, 8. Divide again. 1, 1, 2, 2, 4. So all becomes 1, 1, 1. Okay, therefore you multiply. 3 times 5, 15. 15 times 2, 30. 30 times 2, 60. 60 times 2, 120. Okay, therefore the answer for the given question is the last one. Okay, continue. For question number 3. Okay, this one also you have to do it one by one. I'm just going to show you one of the example here. Using a suitable method, find the lowest common multiple of each of the following list of numbers. For example, 16, 18. So I'm going to use the repeated division method also. So I'll use the lowest prime number. 2, 8, 16, 2, 9, 18. So we cannot use the same number now. No, we can use 2, but then later on cannot. 2 times 4, 8. Copy down the 9. 2 times 2, 4. Copy down the 9. 2 times 1, 2. Copy down the 9. So now we need to change, becomes 3. This is 1, 3, 3, 9. Okay, the 1 you just copy, 3, 1, 3. So it's done over here. Therefore, to get the answer, 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 3, how much? 48. Okay, 48 times 3. Then you get 144. So that's how we get the answer over here. Okay, so next question. I think the next question is on the right. Okay. So this is the one regarding the neon lights. Okay, the picture is very nice. A neon light blinks every 9 seconds, whereas neon light blinks every 12 seconds. Okay, so you have one neon light, for example, this one it blinks every 9 seconds, another one blinks every 12 seconds. If both the lights blink together when the switch is on, so when you just turn it on, it's already blinked. After how many seconds will both the neon lights blink together again? Same thing, you are going to use the LCM to find out the answer. Okay, so both of the number can be divided by 3. 3, 3, 9, 3, 4, 12. 3 again, 3, 1, 3. After that, we use 2 because 4 only can be divided by 2 and then 1. Okay, so the LCM is equal to 3 times 3 times 2 times 2. 3, 3, 9, 2, 2, 4. 9, 4, 36 seconds is the answer. Okay, so you can see the answer over here. Okay, and the last one. Vijaya wishes to pack some souvenirs consisting of a keychain and a refrigerator magnet in each pack for her friends. Keychains are sold in 10 pieces per packet, whereas refrigerator magnets are sold in 6 pieces per packet. What is the minimum number of keychains Vijaya has to buy so that the number of refrigerator magnets she buys can be packed exactly with all the keychains? So the 10 pieces of the refrigerator, keychain and 6 pieces of refrigerator, you are going to find out how many can be packed exactly. So same thing, you are going to find the lowest common multiple for each of it. Okay, we are going to use 2, 2, 5, 10, 2, 3, 6. So over here, the 5 continue, 3, 1, 3. 5, 5, 1, 5, 1. So the answer will be 2 times 3, 6. 6 times 5, 30. Okay, but then the answer, there's no 30 over here, right? So the multiplication of the lowest common multiple, if you cannot buy 30, then you have to multiply it by 2 and 3 and so on until you get the answer. So she needs to buy 60 keychains then. Okay, so let's see. Do you have any question regarding all of this?
No,
No.
understand.
Okay, then we move forward to the next chapter today. The next chapter is very interesting. It's regarding the squares, square roots, cubes, and cube roots. Anybody have ever heard of this word before?
Yes.
Yes, okay, very good. So we go through the introduction part first here. You can see what you will learn in this chapter. Okay, the first thing that you are going to learn, actually this is the first subtopic lah. The first subtopic here is regarding squares and square roots, and then after this you're going to learn cubes and cube roots. Okay, so let us look at what is this silat squad, right? Okay, you can see the introduction given here. The National Silat Squad had won 3 gold medals in the 2015 SEA Games. The squad had shown incredible performances when they defeated the competitors from the other countries. In the Silat competition, our team performed on a square court with an area of 100 meters square. They use this word. What that is about that you are going to learn. How do you determine the length of the side of the court? Okay, if you understand very well, or if you have come to this word before, you will know that the length of the side of the court will be 10 meter. For those who doesn't know how do I get this answer, you don't have to worry. Later on, I'm going to show you. Okay, what does it mean over here? Because they are fighting, they are having this competition on a square court. So meaning that the length and the width of the square court must be the same. So if the area of the square court is 100 meters squared, they were asking how much is the length of the square court. So to get that is actually 10 meter multiplied by 10 meter, you get 100 square meter. So that is how I get the 10 meter over here just now. Okay, now you look at that, right? Scientists use the idea of volume to explain the structure of some cube-shaped crystals. So this is one of it. What is the relationship between the length of the side of the salt crystal and its volume? So what is the relation they were asking about this? Okay, this one is about cube. Okay, I'm not going to enter this right now. I don't want you to confuse it because today we are mostly going to learn about squares and squares root only. Okay, now we look at the right. This one, working through time, we always have to know who are the one that create or the one who originate the theory or the formula and so on. So for this topic, here you can see the name over here, Christoph Rudolph and also René Descartes. Okay, in the year 1637, the symbols of squares and cubes were used by a French mathematician, René Descartes. In his book, Geometry, the symbols of square roots and cube roots were introduced by a German mathematician, Christoph Rudolph. In the year 1525, in his book, Die Cos, or Die Cos, I'm not sure, might be this is reading in French. Okay, and then the word bank, so you can see the word link that you are going to use in this chapter, estimation. The meaning is anggaran. Square is kuasa 2, perfect square kuasa 2 sempurna, cube kuasa 3, perfect cube kuasa 3 sempurna, square root punca kuasa 3, cube root punca kuasa 3. Okay, let's continue with the next one. Now, we are going to enter the first subtopic, which is the squares and square roots. So you can look at the picture of the two old men. What are they doing over there? Okay, look at the instruction there. Sorry, I crossed this first. Okay. About 2,500 years ago, a group of academics created patterns of numbers in the shape of squares by arranging pebbles in equal number of rows and columns. So you can see the pebble that they arrange over here. Start with 1 pebble. Okay, and then this is 4 pebbles, this is 9 pebbles, and then this one is still continue. He is going to put this one here. Okay, meaning that this is 16 pebbles. Okay, now we look at the last sentence given. Are you able to determine the next pattern of square? So how do we determine? I'm sure you can observe what is the similarity over here, right? Because the first one is 1 pebble, followed by, you can see the side 2 pebbles. This one 3 pebbles. This one 4 pebbles. Of course, the next one will have 1, 2, 3, 4, 5 pebbles. So we are going to finish it, which means this is a 5 times 5 pebbles. Okay? And the rest, when they ask to continue, you are going to get 6 times 6 pebbles and so on. Okay? So that is related to what we are going to learn today, which is square. Okay, how do I get all the numbers over here? I think we don't have to go through the exploration activity one. I'm going to go directly into the second part over here about the perfect squares. Okay, you have learned all the number from number 1, 2, 3, 4, 5, 6, 7 up to 10. Okay, what are perfect square? Actually, perfect square is the square of a whole number. Okay, so for example, if you look at this table here, you're given number of pieces of paper with size 1 unit times 1 unit, and then they ask you, can the arrangement form a square marked thick or not? Okay, number of pieces of paper, 1 times 1. So when you find out from the exploration activity, it's found out that only a certain number of pieces of paper with size 1 unit times 1 unit can be arranged to form a square. Okay, and then the number of pieces of paper that can form a square in the activity are 1, 4, 9, 16, and so on. What does it mean here? Because you see, this one piece of paper, 1 times 1 unit, which means this times this is 1. It can form up a square. That's why we have a tick. And then for 2 pieces of paper, which means this times this. So it doesn't form up a square, right? That's why they give it a cross. Same with these 3 pieces of paper with the 1 times 1 unit. So you also cannot form up a square. But then 4 we can form because it's like this. 1, 2, 3, 4. We can form up a square. Okay, so that's why it's a tick. Then when it comes to 5, you add on another 1. So we cannot have it until 9. Why? Because we can form up 9 pieces of paper together to form up a square. Like this. And so on. Okay? So you can look at the next paragraph here. The numbers of pieces of paper that can form a square in that activity are 1, 4, 9, 16, and so on. How do I get this number? Simple. You just need to memorize this stuff from now on. 1 is equal to 1 times 1. Okay, that is the meaning of the side. 1 unit times 1 unit. So you get a 1. Actually, it's 1 unit squared in the middle. And then the second one, how do I get 4? 4 is equal to 2 times 2. 9 is equal to 3 times 3. 16 is equal to 4 times 4, and so on. So the meaning over here, you have to memorize on your own. Is actually 1 squared, 2 squared, 3 squared, 4 squared. 4 squared. That's how you get all the answer. 1, 2, 2, 4, 3, 3, 9, 4, 4, 16. Okay, next question over here. They ask you to state the subsequent perfect square. These are the perfect square, okay? The number over here, 1, 4, 9, 16 are the perfect square because it is a square of a number. Okay, can you tell me what is the next number of the perfect square?
25.
Very good, 25. Okay, so
25.
yes, because 5 squared you get 25. 6 squared we get, what is the answer?
36.
Yes, very good, correct. So 7 squared we get 49. Okay, I want you to memorize all of this. So I'm going to continue it. 8 squared, 64. 9 squared,
81.
yes, correct. 9 squared, 81. 10 squared, 100. 11 squared, 1, 2, 1. 12 squared, how much?
144, sorry.
Very good, 144. 13 squared, 169. 14 squared, 196. 15 squared, 225. Okay, I want all of you to memorize the perfect square. Okay, meaning that you memorize all the square of the number from number 1 until 15. Okay, which means whenever I ask you what is 11 squared, you can give me 121. What is 14 squared? Directly you can give me 196. Okay, can or not?
Can.
Can.
So later on, I'm going to ask you to memorize within 1 minute, and I'm going to call for anybody to answer my question. Okay, so I continue first. We look at the picture here on the right. Okay, this part here. How do you determine whether a number is a perfect square? Okay, look at the arrow here. We can use the method of prime factorization. Again, hopefully you still remember what is the prime factorization method to determine whether a number is a perfect square. Okay, in this method, if the prime factors can be grouped into two identical groups. Okay, this one is very important. I'm going to let you know what does it mean by these two identical groups. Then the number is a perfect square. For example, if you look at example 1 here, determine whether each of the following numbers is a perfect square. So 36. To get 36, they divide it into 4 times 9. 4, 9, 36. So 4 is the multiplication of 2 times 2. 9 is the multiplication of 3 times 3. So 36 is equal to 2 times 3 times 2 times 3, whereby they group the number together to balance it up. Okay, take one from here, take one from here. So it's 2 times 3. Take one from here, take one from here. 2 times 3. That is what we call the two identical groups. Okay, when we can group them into two identical groups, meaning that this number here, 36, is a perfect square. Okay, now we check the one which is not a perfect square. So number 54 over here is not a perfect square. Why? Because you can see 54 is equal to 6 times 9. And then 6 is equal to 2 times 3. 9 is equal to 3 times 3. But then if you look at the number, 54 is equal to 2 times 3 times 3 times 3. We have 3, 3, but then we only have 1, 2. We cannot make them into two identical group like just now, whereby it can be balanced up two numbers with the same one into two identical group. Therefore, 54 is not a perfect square. Okay, I'll give you one more example. For example, this one. 3, 2, 4. I'm going to do it on the right. So can you have the answer in your mind right now? First, 3, 2, 4. You guess it yourself whether 3, 2, 4 over here is a, what do you call it? Perfect square or not. Make sure you know this word, perfect square. Okay, so now we are going to start the calculation. 3, 2, 4. Can you imagine 3 through 4 is the multiplication of what number? I think I have to show you this. Okay. 3.
160.
Pardon?
162.
Okay, I try to divide by 16. See whether we cannot already have to get a full number. For example, divide by, if I divide by 8, 40.5. Okay, if I divide by 3, 2, 4, divide by, what is the number that you want to use? 9? Okay, you can use 9, right? Okay, let's see. If 9 with 36, 9 with 36. Okay, let's try first. 9 with 36. So this part is easy. We get 339. What about this? This will be 3 times 12, right? And then this part will be 3 times 4. And then this one will be 2
times 2.
Okay, so basically 3, 2, 4 is equal to, we get all the smaller number first, 2 times 2 times, so we have 1, 2, 3, 4, 4, 3. 1, 2, 3, 4. After that, we are trying to group them into two identical groups. So we have 2, 2 over here. I'm going to separate it. And then we have 4, 3. So we can group them into two identical groups exactly. Right? Okay, then we check. 2 times 3 times 3 is equal to 2 times 3 times 3 is equal to what? I proceed to further.
80.
Okay, never mind. I stop here. We continue with that part later on because you are confused. Okay, so when we can group them into two identical groups, meaning that 3, 2, 4 is what, class? Is a
Perfect.
very
Perfect
good.
square.
Yes, perfect square. You have to read this word yourself, perfect square. Get used to it. Okay, it's a perfect square. Okay, now we move on. Later on, we have to continue with this part here. Just now, you stop over there. Okay, now let's see the next page. Okay, it's the mind exploration activity again. We are not going to do that. Yeah, this part. I want you to look at this part. So 6 squared is equal to 36. It is written in this one. We call it 6 squared. Okay, so when I want to find out when we are given a perfect square over here, go back to the left, we are calling them the square root. Okay, so let's go through which part, let me see, is important for you. Here. Okay, this is the symbol of square root. Okay, I'll let you see again. We start from here and then go to the right. You don't simply do and then like this. No, because I saw some students, they also like to do like this. No, there's no such thing. You just follow exactly and then you got to practice this. It's just like a tick and then go horizontally to the right. So when you have this, we read it as square root of 36. Okay, so 6 squared is equal to 36. When they ask you to find the square root of 36, it is actually equal to 6. How do we get that? I'm going to show you how do we get this. This part is too fast already. Okay, wait. I'll show you the same thing. 6 squared is equal to 36. So when it comes to square root of 36, it is actually equal to 6 times 6. If you look at the number here, right, it's the same. 6 times 6, 36. So when you continue, it becomes 6 times 6 is 6 squared because we have 2 6 over here. So we write down the 2 here. Okay. And then when it comes to the answer, because this is the question, when it comes to the answer, you cancel the square root with the square. So the answer is 6. Therefore, the square root of 36 is equal to 6. I'll show you another question here. For example, 49. They're asking, what is the square root of 49? If you're fast, you can get the answer. But then,
7.
yes, very good. But then when they ask you to show the step later on or they ask you to fill in the blank, then you have to know what you should fill in over here. They will give you something like this and then answer. So you need to know what you should fill in. Over here, to get 49 is actually 7 times 7. So 7 times 7 here, we simplified becomes 7 squared because we have 1 7, 2 7, so we write down 7 squared. And then cancel the square root with the squared, so we get the answer as 7. Okay, now we look at example 2 given. Tell me if you have any question, you can stop me. So in this question over here, they ask you to complete each of the following. See, like just now I asked you, in the question, they will ask you to fill in the blank. So they already give you this as a guidance. 9 times 9 equal to 81. What is the square root of 81? So 81 is equal to the square root of 9 times 9. You just fill in this one that is given. Okay, directly now they give you what is the answer over here without the square root sign. So you can see if without the square root sign, like just now, if you were asked to write down 9 squared, right, after this step. So you can cancel the square root with the squared. So the blank or the text box without the square root over here, you should fill in 9 only. Okay, sometimes they will skip this step. They will ask you to proceed to the last answer. So you need to see carefully, is it without the square root or with the square root? Okay, now we look at B here. 32 squared is equal to 1024. So what is the square root of 1024? So this one is easy. You know that the square root of 1024 is equal to square root of 32 times 32 because they have given you the information already. Therefore, it is equal to the square root of 32 squared. Cancel the square root with the squared, so you get a 32. So over here, you see they give you this format. So you know already you should fill in this is 32, this is a 2. Okay, and the answer is 32. Understand, class?
Yes, ma'am. Yes, teacher.
Good. So,
Yes, teacher.
okay, good. Okay, now let's see example 3, that is to determine the square of number. Okay, I'm not going to continue with this first. I'm going to give you 1 minute right now. As what I've told you, you need to memorize the perfect square. Okay, so for example, I ask you to list down, give me the first 5 perfect square. Then you can give me directly the first 5 perfect square that are here. 1, 4, 9, 16, 25. These are the first 5 perfect square. Or I will ask you, give me the perfect square after 64. So after 64, the perfect square is 81. Or I will ask you, what is the square of 13? So square of 13 is 169. Okay, so I give you 1 minute. Is it enough? 1 minute? 2 minutes right now. Okay, I give you 2 minutes. It's 12:01 right now. So 12:03 later on, I'm going to call upon your name and then you need to answer me question. So you may start now. Memorize all the square number from number 1 to 15. Have you all memorized?
Yes.
Yes,
Yes.
huh? Any problem? No problem, right?
Yes.
Yes.
Okay. Let me test you, some of you over here. Let's see. Amelia, are you there? Amelia, this one. Emilia, are you there? How come there's no feedback then? Oh, okay, Amelia. What is the square of 9? Squares of 9. 9 squared. Can you give me the answer, Alia? Can you give me the answer, Alia? Habib, yes, you may go. Okay, Alia, what is the answer for 9 squared?
81.
81, yes, good, thank you. I think I missed out something on how to read the number over there. Let me show it to you. Some of you might don't know how to read it. For example, if you look at this small, what do you call it? Is it a grasshopper or what, or a robot? Okay, 4 squared. 4 squared, this one is read as 4 squared or the square of 4. So if I give you 9 with the 2 there, it means 9 squared. Okay, 9 squared or the square of 9. Okay, so make sure you know how to read it. 9 squared or 9 squared of 9. And then if I give you 8 like this, so it is 8 squared or square of 8. Okay, so let's proceed to the next person. Let's see who is the lucky one now. Okay. Erwin, are you there?
Yes,
Erwin, what is the square of 5?
25.
Thank you. Next person. Alicia, are you there?
Yes.
7 squared equal to?
49.
Thank you. Next one. Nurul Alia, are you there?
Yes.
What is the perfect square after 100?
121.
Very good. Thank you. Next one. Azizi, are you there?
Yes.
What is 15 squared? Azizi, what is 15 squared?
225.
Okay, good. Thank you. Next person. Iskandar, are you there?
Yes.
Iskandar, what is the perfect square before 225?
16.
No, before 225. What is the
Oh,
unit line?
196.
Yes, very good. Thank you. Next person. Valerie Clarista.
Yes.
Okay,
Yes.
Valerie, what is 13 squared?
196.
Check again.
99.
13.
69.
Yes, thank you. Very good. Next person. Elijah. Are you there?
Yes. Yeah.
What is the perfect square after 25, Elijah? What is the perfect square after 25? Elijah?
32.
Again?
32.
Okay, 32 is not the correct answer because I was asking for the perfect square after 25, meaning it is 6 squared. 6 times 6 is what, Elijah? 30?
36.
36.
Correct.
36.
36, yes, good. So,
I meant to say 36.
okay, sorry everyone, I mispressed again. Is everybody still here?
Yes.
Yes.
Okay, good. So go back to what we have, I've tested you just now. Make sure everybody can memorize from 1 squared until 15 squared. That's the list of the number. So I'm going to continue now. If you look at your GC, everybody, I want you to take your attendance before we end the lesson. So you go to your GC again as usual because I already set the due time. So look at the attendance for today, 15th of March. I have 53 over here in Google Meet, but then I only have 34 turned in. So can you please do so right now? I want to make sure everybody is in.
Done, madam.
Done. For those who haven't done, you can see the name. For those who haven't taken your attendance. Okay, please take your attendance right now. Okay. You do it after you have taken your attendance. So I want you to do the exercise for today, including those who haven't finished the exercise for last week. Make sure you go back, you do the Google form. So the exercise for today is this one, the squares and square roots. Okay, this one. I attach the live worksheets again. This is the one. So I want you to solve all of this, fill in all the text boxes given. Like usual, after you press the finish button, you capture the mark of your screen on top of the left corner for me. After that, attach or turn in into your GC as usual. You got me, class?
Yes, teacher.
Yes.
Okay. So, do you want me to discuss this directly? Maybe give you a 5 or 10 minutes to solve the problem, or you want me to discuss it in the next lesson?
Next lesson.
Next lesson.
Okay. Okay, next lesson. So I'm going to summarize what you have learned today again. So first of all, what you have learned today is to find out the square of the number. Okay, 1 square, 2 squared, and so on. So you got to know how to read it. Okay, 4 squared or square of 4. And then you know that the square of a whole number, we call all of this perfect square. Okay, perfect square. After that, you learn to find the square root of a number. Before that, you learn to find how to get a perfect square. Okay, by using the two identical groups. After that, you learn to find the square root of a number using the symbol of the square root like this, and figure out how to fill in all the blanks given, like example 2. Okay, so hopefully you can get through it. In the next lesson, I'm going to talk about this one, how to determine the square for number. So you can see we are going to learn on how to use the calculator. So in the next lesson, make sure you get ready with the calculator with you, and then we are going to try to do all the exercise in here. Okay, so that's all for today. Thank you, class. See you on Thursday.
Thank you, madam.
Welcome.
Thank you, madam.
Thank you, madam.
Bye.
Thank you,
Bye.
madam. Bye.
Bye.
Bye. Thank you. Thank you.
Bye.
Bye. Bye.
Yeah, you're welcome.
Okay, thank you, madam.
Okay, bye.
Bye.